Hey guys, so in this video we're looking at systems of linear equations in 3 variables this time instead of 2 variables like the last section. In the last section we had graphing, substitution, and elimination. In this one we're just really sticking to elimination. Like I said in the last video, this is sort of the workhorse of the solves. And in that last one, remember, we had 3 outcomes. We could have where it had 1 solution, it could have no solutions, or it could have an infinite number of solutions. We have those same 3 outcomes in this section. The language they use to describe that changes a little bit as you go forward in math, and so we're going to pick up a couple of new terms, so I just want to get those introduced. I'll talk briefly about the geometry of what's going on, and then we'll do it all algebraically. So when you get 1 solution on these, it's like this figure right here, and this is the first page of the notes, so you can certainly pull this up from the lecture notes. But you can see it's 3 planes, they're intersecting in space at that 1 point right there in the middle, and so that 1 point would be your solution. So that's the equivalent of the 2 lines crossing. Dependent. So dependent is going to be our infinite solutions, and dependent is the word they use to describe that kind of going forward. So a dependent system would be like B here, where you can see all 3 planes, that's representing our 3 equations, intersect in the line. So that line would go on forever, and that line makes up infinite solutions. So notice that's different than all real numbers or something. It's there's lots of things that don't work, but there are an infinite number of answers that do work. Third outcome is our no solution, and then the word for that's going to be inconsistent. And so you can see 3 drawings where the 3 planes are orientated so that they never cross. And all 3 of them don't cross at the same place. So that's kind of the geometry behind it. You can see drawing this would be insanely hard, so that's why we don't do the graphing method for this. For this next part, we have steps for solving systems. And there's a really specific plan, and it works pretty well. And if you just kind of figure out what your goal is, there's a fair bit of math in these problems. It's not hard math. It's really easy to make errors in terms of the signs. But the math itself isn't hard. You just have to kind of know where you're going with it. So I'm going to talk through these steps as I do this first example. And see if I can kind of get you to see just sort of what the game plan is for the style problem. So step 1 is we pick any pair of equations and solve for 1 variable. And then step 2 is pick another pair of equations. So if I picked 1 and 2 the first time, I could pick 1 and 3 or 2 and 3 is kind of the deal there. So pick another pair of equations and solve for, super important right there, same variable. So we got to eliminate the whatever variable we pick twice. So let me just show these 2 steps with this problem right here, which is our first example. So I'm going to eliminate, which one did I do? I'm going to stick to the notes. There's one of the things about these is there's an infinite right way to solve them. So you'll see me do 1 solve here. In my notes, I decided I would eliminate y, but I could have eliminated x or z. We would have entirely different work. Oops, one minute. Sorry, dropping stuff. We would have entirely different work, and we would get the same answer. So just to be consistent with the notes, I'm going to stay with the y's. So I'm going to use 1 and 3 for this first move. And then the labeling I do, there's a little bit fancier one that you'll pick up probably in 141. But for right now, I'm just going to label the equations 1, 2, 3. I'm throwing them in circles so that they don't look like I'm multiplying something. And this will make it a lot easier to track. You're going to see it's going to fill this whole page. So we got to kind of have some way of keeping track of where we are and what we did. So I'm going to do equation 1. Get that written down. And I'm trying to eliminate the y's. So I'm going to multiply equation 3 by 2. And that's going to give me a 2y negative 2y. So I'll go 2 times equation 2. So I'll be 2x plus 2y plus 2z makes, and then right here is where people make the error, 2 times negative 4, negative 8. It's really common to forget to multiply the other side. So then I can add those and get 3x, that drops out, so then plus 4z equals negative 8. And then I call this one equation 4. And you'll see one, just for following me through the notes, you're going to be happy I had names for these. The second thing is, like I said earlier, these are really prone to sign errors, or at least I'm really prone to sign errors when I'm doing these, and I've graded it a million times, and everyone's pretty prone to sign errors on these. So there's a lot of, you get to the end, you get a crazy answer like, 7/3, and you're like, I know that's not right. You end up having to go back through your work and try to find where you made the sign error. If you've written down what you've done, it will make it much easier to kind of go back and go, okay, this is 1, 2 times this, 2, 2, 2, -8. Okay, that's cool. But it makes it much easier to go back and kind of figure out where those errors happened. Also makes it easier for me to grade, which is much appreciated. So anyhow, so I've done my first step now, and then the second step was pick another pair of equations, solve for the same variable. So the same variable part is really important because otherwise what we just did here was made an equation with 2 unknowns. I need to have the same 2 unknowns for the next equation because then I'm going to put those together and eliminate a variable, and then I'll have my answer. If I do a different variable, I still have 2 equations, but now I have 3 unknowns and I can't solve it. So once I picked y in step 1, I have to pick y in step 2. And so for me, I did, I'm just going to do equation 2 here. And again, there's lots of right ways to do this. So the steps you see me taking, there's nothing special about them. This was just kind of the way I solved it, and I could, solve it half a dozen different ways. But this is just one version. And then I'm going to go to the negative of 3. And so what that's going to do, I have this plus y, that'll give me a minus y, and then those are going to cancel. So I'm just multiplying all that by -1, that's a z. And then that gets me 5x, y's drop out, plus 2z equals 10. And I'm going to call that one equation 5. So now once I have 4 and 5, we're at step 3. You've created a system of 2 equations and 2 unknowns. Solve the resulting 2x2 system. So now we're right back in the last section. I just have these 2 equations. So it's a little 2 equation, 2 unknown system. And looking at this, I could do the 3's and the 5's, or I could do the 4's and the 2's, and that seems easier. So I'm going to do eliminate the z. So I'm going to go equation 4, which is right here. And then I'm going to go -2 times equation 5. So it's going to be -10x minus 4z equals -20. And now I can eliminate these. So this is just like what we did in 3.1. And then I got -7x equals -28. Divide the 7 over and get x equals, and that'll be double negative, so +4. So now I got my first solution. So now we're back to step 4, back substitute known variables into any of the original equations. And so actually I guess we're at the end of step 3, solve the resulting 2x2 system. So I have 4, so now I can go back to equation 4 or 5 and finish solving this one. And then step 4 is to go back to 1, 2, or 3 and get our last variable. So here's 4. So I'll just toss it into, it doesn't matter which one I'm going to toss it into, 5, just because. So that'll be 5 times 4 plus 2z equals 10. 20 plus 2z equals 10. Take the 20 over. And 2z equals -10. And divide out the 2. And z equals -5. Now once I got that, there's my x, there's my z. So now I can come back to one of these equations with all 3 variables, and number 3 looks the easiest, so that's the one I pick. There's no reason to do more math than we have to. So there's my 4 going in for x plus y plus z, so that plus a -5 is just -5 or -5 equals -4. And now I can go 4 minus 5 for -1 equals -4. Add the 1 over, and I got y equals -3. So that's my 3 solutions. To put them in the computer, we're going to write this as an ordered triplet. So that's going to go 4, -3, so we want to go x, y, z, and then -5. And that would be our solution. So these ones are a little bit of a commitment. They're not terribly hard. Kind of, I think what makes them hard is not knowing what you're trying to get to. And I see people just kind of wander off in this first couple steps. And so I'm just going to talk through it one more time, because if you know the plan, it's a bunch of not that hard math. There's a lot of it, but it's not the hardest thing ever, if you know where you're trying to get to. So just to recap, we have 3 equations. I'm going to pick a variable, whichever one seems the easiest. So I chose y, but I could have done x or z. And we're going to eliminate that variable twice. So we're going to do 2 equations, eliminate the variable. We'll do 2 different equations, but eliminate the same variable. Super important, same variable right there. Otherwise you're stuck. And that's where it goes wrong on the test. Once I have 4 and 5, I can put those 2 together and then solve for whatever is easiest and get my first answer. Once I have my first answer, I go back to either 4 or 5 and I get my second answer. Once I have my second answer, now I got 2 of them, I come back to equations 1, 2, or 3. I put those in and I solve for my third answer. So that's basically a 3 equation, 3 unknown. I'm going to do like 5 more examples now. I'm going to talk a little bit less for the next ones. But there's just, a lot of it is just having a good plan. That's what sort of being successful in these are. The other thing is, don't try to do too much in your head. You see me writing out a lot of steps and kind of labeling stuff. It's sign errors. It is what's going to get you here. So kind of having some fairly decent accounting so that you can kind of keep track of your work. That's also going to really help. So this next one is the matched problem I would have you guys do in class. This time, looking at x's, y's, and z's. I went with the z's. None of these are terrible. The y's are pretty nice too, but I happen to pick z's, so I'm just going to do what I did in the notes. So let me bring that down here. I went with 1 and 3, so that's pretty easy. I don't have to do any kind of rewrites. So if I do 1 and 3, x plus 2y plus z equals 3. Copy this one down. And so then here I got 4x plus 3y, z's drop out, equals 8. And so that is going to be my equation 4. And then for the next round I did, let's see, I think I did 2 times equation 3. I did a negative, so this becomes negative 2 and then 2. So I'll do equation 2. And then I'm going to go 2 times equation 3. So 2 times 3 is 6x, 2y, and then 2z, negative 2z, and a 10 on that side. And that's always a good spot, just to go back and go 2, 2, 2, 2, because that's usually where the errors are, or also in the addition, I guess. So then this is that drops out, and I got 16. So that is my equation 5. So now that I got that, I could either do a 3 across this one, or I could do a 2 across this one. Either way, it works out fine. In the notes, I went with the 3. I kind of like the 2 better as I look at it, but I'll go ahead and do the 3. So I'll do equation 4 and then negative 3 times equation 5. So that's going to be 4x plus 3y equals 8. And then this is going to give me negative 24x, negative 3y, and then that'd be negative 48. And adding those together, I got negative 20x equals negative 40, divide my negative 20 over, and x equals positive 2. So then, once I have that, I can come back to either equation 4 or 5. I went with 5. So this would go 8 times 2 plus y equals 16. So this is 16, mine and 16 on both sides. So I get y equals 0, and that can happen, just means the y value is 0. And then now that I have x and y, I can come back to 1, 2, or 3. I arbitrarily chose 1, so just do that here. So it's going to go 2 plus 2 times 0 plus z is what we're looking for, equals 3. So that drops out, so I just have 2 plus z equals 3, take the 2 over, and z equals 1. So solution set, all written nice, would be 2, 0, and 1. Okay, for the third example, you gotta like these x's up here, right? Because they're just all set up to drop out. So if I do that, let's see, I could do maybe 1 and 3, and then I'll do 2 and 3. So negative 3x plus 4y plus 2z equals negative 16. And then we'll do 3. And then x's drop out as planned, and I got 7y, I think that's supposed to be a 3, plus 7z equals negative 6. So that's my equation 4. And then I'll go 2 and 3. So negative 3x plus 3y plus z equals 5. And then equation 3, 3x plus 3y 5z equals 10. Okay, so those drop out, and remember, killing off the same variable, 6y plus 6z makes 15, and that's going to be my equation 5. And so now I can put 4 and 5 together. You can kind of see that there's some funny stuff's going to happen. I did negative 6 times equation 4, and then 7 times equation 5. So that'll get me 42's in both of those. So negative 42y, negative 42z equals 36. And then 7 times this one will get me 42z plus 42z. And 7 times 15 is 70, 105. And then you see what happens, right? All that dropped out. So that is 0 equals 141. And that is a false statement. So that is the no solution kind, or inconsistent. Okay, and this is the matched one I'd have you guys do in class. For this example, I went with eliminating x's. Again, you could do any of them, but the x's looked kind of the easiest, so that's what I pick. And so I'm going to do equation 1 and negative 2 times equation 2, and that's going to get me those. So 2x plus y, 3z equals 1, and then a negative 2 across here, so negative 2x plus 4y plus 2z, that will be negative 6. So that drops out, and I have 5y minus z equals negative 5. So that's my equation 4. And then my next one, I did a negative across this to get negative x positive x. So I'll go the negative of equation 2. So negative x plus 2y plus z equals negative 3. And then we're doing equation 3 with that. Oops. So that's going to give us the x's drop out, 10y right there, negative 2z equals negative 10. So that's going to give me equation 5. And now I could do a negative 2 across equation 4 and use that to eliminate. So negative 2 times equation 4 would be negative 10y plus 2z equals 10. And then equation 5, 10y minus 2z minus 10. So it drops out, drops out, drops out, so you're at 0 equals 0, and then that is dependent, which is our infinite solution one. So this next one is a little bit different. It is 3 equations, it is 3 unknowns, but each equation only has 2 of the 3 variables. So the solve is actually easier unless you don't listen to the next part, in which case there's a step where you just kind of cycle around trying to get equations and they never work. But it is actually easier if you know the trick. So this is equation 1, 2, 3. I'm going to pick something to eliminate. It really doesn't matter which thing I go with. I decided to do, in the notes, I saw the 2z and the minus 4z. I thought that looked pretty easy. So I'm going to go 2 times equation 2. So that'll be 2y plus 4z equals 4. And then we add to that equation 3. And careful with your like terms, because that 6 and the y do not go together because this x's and y's. And then this side was equals 1, sorry. So now when I add, I got 6x here. This is a positive 2y. My z's drop out, and that equals 5. So, you know, I had two equations. This one had y and z, x and z, and now I just made one in x and y is pretty much what happened. That's my equation 4. So now normally you would do two different equations. You do 1 and 2 or 1 and 3. If you try to do that, you're going to get a third or a second equation that doesn't have the same variables. You'll just keep cycling and cycling and cycling through different iterations of equations and never get one that you can work with to get this. So the trick here is not to make an equation 5. I just did 2 and 3 together. And if you look, equation 1 is totally set up, right? It's the x and the y already. So you don't need an equation 5. You just need to go back and use the one you haven't used yet. So that's the spot where if you don't listen to that part, you're not gonna ever solve it. You're just gonna keep making new equations that won't work. So once you get 4, use the one you haven't used. So if I had done 1 and 2 together, I'd be using equation 3 as my equation 5. So anyhow, I'm gonna go probably the negative of equation 1. And so that's going to go negative 3x minus 2y equals negative 3. And I'll just bring equation 4 over. And then there's 3x, y's drop out, equal 2. And this one comes out fractions, but sometimes they do that. So x is 2/3. Although I just said that, on my exam, they never come out fractions. So if you're getting fractions on the exam, stop right there and go back and find your sign error. Once I have x is 2/3, I can plug that into any of these other equations that have an x, so either 1 or 3, and use that to get y or z. So I'm going to go with, I'm putting in equation 1, so 3 times 2/3 plus 2y equals 3. So the 3's cancel, and I have 2 plus 2y equals 3. Let's scoot that 2 on over. 2y equals 1, and y equals 1/2. And then once I have that, I can go back and get z. And so I'll go with equation 3 here. So this would be 6 times the 2/3 minus 4z equals 1. So 3 goes into 6 twice. 2 times 2 is 4. Scoot the 4 over. Get negative 4z equals negative 3. And then dividing, is that double negative again? So z equals 3/4. So our solution would be 2/3, 1/2, and 3/4 for the last one. So in this one, I saw those z's again, so I went ahead and did that. So I'm going to go 2 times, I'm going to go equation 2, and then I'm going to go 2 times equation 3. So 3y minus 2z equals negative 8, and then this will be 2x plus 2z equals 2 times 5, 10. So 2x plus 3y equals, those dropped out, 2. And so that's my equation 4. And I could have totally eliminated x's or y's. The z's had opposite signs, so that's why I picked them again. With my equation 4, I've used 2 and 3, so that means it's equation 1 again is going to be the one that I want to use as my equation 5. So I think I will just multiply that by a negative. So negative of equation 1 would be negative 2x minus y equals negative 6. And equation 4, just bring that right underneath. So those are gone. That's a 2y. That is negative 4. Divide that over. And oops, y equals, that's not very good, negative 2. Or 4. There we go, negative 2. So once I know y equals negative 2, I can come back to either of these earlier ones. So I'll just pick equation 1. So 2x minus 2 equals 6. 2x adding the 2 equals 8. Divide both sides. X equals 4. And once I got that, I can come back and get z. Got it like equation 3, it looks easy. 4 plus z equals 5. shoot the 4 over, and z is 1. So my solution set is 4, -2, and 1.